Today we will do anti-differentiation. So anti-derivatives or integrals. So we'll do a table again of the common functions. So they are the opposite of differentiation. So if we start, for example, with most obvious one, we know that logarithm of x has a derivative of 1 of x. So 1 divided by x on the power of minus 1. So therefore, let's make a table again. We have f of x, and we have an antiderivative or integral of f of x. So the first one we go, so if it's, say for example, from 1 over x, that's a logarithm of, that's the absolute value of x for the base of e. And similar, more generic case would be the when we have a function, the first derivative divided by the function itself, and that's the same as logarithm of that function. And then most common ones are obvious, like sine and cosine. That's just what we know. So if you want some of them, like you know that derivative of the first derivative of sine is the cosine. So if you say that cosine of x, then you will have a sine of x. And say you also know that the first derivative of cosine of sine is the cosine. So now we have of first derivative. So say that the function is sine of x, and obviously there will be a cosine, but minus cosine of x. More generically said that cosine of ax plus b becomes 1 of a times sine of ax plus b. And similarly, sine of ax plus b becomes minus 1 over a cosine of ax plus b. So that's what they devised them, right? So those are the basic ones. So that's all in reversals of the derivatives. So maybe we can do a bit more there. Say for example the basic one. Say the basic one would be x on the power n, and its derivative, so that's f of x in this column, and it here is an integral of f of x, so that would be 1 over n plus 1 times x on n plus 1. It's like the powers were going down and the powers will be going up because we're doing the reversal. So that's the basic one. The logarithms we've done. What else? Oh yeah, there is one of e in the power of a. That's a simple one. E on the power of ax plus b, and that's 1 over a. So it's always 1 over something. On the other side, 1 divided by e ax plus b. And we've done sine, cosine. It's okay. So what else is left? Our tangents, yeah. So from tangents we have a second, so a second will be then to return back to tangents, right? So second square of ax plus b will be 1 over a times tangents of ax plus b. So that was that. What else is left? I think, oh yeah, we have the logarithm we've done. Okay, so what else is left? Oh yeah, inverse trigonometric functions. So what do we have? We have then 1 over something. That was always the case. So maybe we just go to the generic ones for them, just to say that, say f prime of x over square root of 1 minus f of x on the power of 2. That reminds us of arc sine, the reverse sine function. So it's sine on the power minus 1 over f of x. And similarly, for the cosine, the reversal, we have got the minus at the top, f prime of x divided by, that's a new function, the steps here, and the denominator is the same, f of x on the power of 2. And that's for, obviously, for cosine and the power minus 1 of f of x. So, oh yeah, maybe tangents, we're just missing the tangents one. Oh, we can do that there down the bottom. So that will be, what have we have with the tangents? We have f prime of x divided by 1 minus 1 plus, because tangents is plus 1 plus f of x on the power of 2. And that's our tangents, reversal tangents. That's tangents on the power minus 1 of f of x. So what's interesting to note with these integrals is that each of these will have a plus c, some constant. The same here, plus c, the same on this side, plus c, and that constant, what it is. So when we reverse back to the function, the original function, so we apply, say, we have a function f of x, and then if we apply differentiation by dx, and then we apply an integral, then we are back to f of x. But we don't know, it comes with a family of functions. For example, if the function f of x was this function, when it returns back, it returns it but as a family of functions, so you don't really know which one of them. So if you then fix one point on your of the independent variable there, then you can say that function. So you need to say for the point x equals 1, I will have, and then it will be. So that's that c. Once you know the c exactly, the value of c, then you will know which one is there. And usually you use one example. You say, I want the integral of this function at the point of x equals that, and then you get one function back. And that should be enough for today. Here we've forgotten to say differential by dx. So basically what happens, at the end you get that, and you're left with only f of x.